Hello, Newton's laws, a hill, and the conservation of momentum. We will use Newton's laws to analyze a problem and apply the laws of the conservation of momentum to solve the problem. A cart weighing 25 newtons is released from rest on a 2-meter ramp, inclined at an angle of 60 degrees, as shown in the figure below. The cart rolls down the incline and strikes a second cart weighing 40 newtons. A. Calculate the speed of the first cart at the bottom of the incline. The ultimate point of this problem is to A. Measure the amount of momentum cart 1 has at the bottom of the incline, and 2. Knowing the momentum that cart 1 acquires at the bottom of the incline, it will collide and stick to cart 2. Now, it will then have an unknown velocity. Using the conservation of momentum, we will determine the final velocity of the two-car system after the collision. Also of special note, there is no coefficient of friction mentioned in the problem. There will not be any friction in this problem. And Fp will be equal to F net. Now, the first thing we want to do is calculate the velocity that car 1 acquires at the bottom of the hill. Hello. On this slide, there are several things. The table of the knowns and the unknowns, the equations I need to calculate the first part of the problem, and that is the velocity that cart 1 will acquire at the bottom of the hill. Notice there is no friction, there is no coefficient of friction, there will not be any friction. Fp will equal F net, and it is up to you to determine why that might be true. Hello. Listed on this slide is a considerable amount of information. On the left of the table, I calculated various quantities. The mass of car 1, the mass of car 2. Those calculations should be self-evident and they should be very clear to you. Fp should be a standard calculation for you at this point. And also, as mentioned before, there is no friction, so Fp will equal F net. You should ask yourself, do you understand that? Why is F net equal to Fp? If you don't understand, ask me in class. Acceleration, as you know, is a quotient of F net over its mass. Now, also listed is the initial velocity of both cart 1 and cart 2. The final slide contains the ultimate answer. Now, to the left of the table, there are calculations, the actual velocity of car 1, the fact that the law of conservation of momentum states that the initial momentum equals the final momentum. Now, I calculated the initial momentum. That is the mass of cart 1 times its velocity, the mass of cart 2 times its velocity, and I find that cart 1 is 2.5 kilograms, the velocity it achieves is 5.9, the mass of cart 1 times its velocity is 0. That's going to be the initial velocity of the cart before it strikes. The entire momentum, the entire introductory momentum is generated by car 1 accelerating and attaining a velocity of 5.9. Then you take that mass, multiply it by its velocity, 5.9, and that's the total absolute momentum that's going to be involved in the system. Now, that's going to be 15. I set that equal to the product of the mass of car 1 and 2, because they're sticking together, times the velocity of cart 1 and 2 is what we're calculating. 15 equals 6.5 times the velocity. Dividing through by 6.5, we get the velocity of cart 1 and 2 stuck together as 2.3 meters per second. Again, if you have any questions about any of this problem, be sure to write them down, or you can comment me on the YouTube page directly. Thank you very much. Have a good day, and goodbye.